bear with me. I want to go over 2.5 and 2.6 today. Not a lot. It's not a lot to cover. It's basically the decay and increasing and decreasing functions. And I just want to get into that with you a little bit. I want you to write down this function right here. P of t is equal to P sub O, which is your initial, times e to the negative kt. Now, I don't know if y'all remember me telling y'all this, but remember PERT? Remember we were talking about compound interest before? It might have been in the review section. Do y'all remember me talking about compound interest? Yes or no?
Yes, sir.
A is equal to P times 1 plus R over N.
Yes, we remember.
Okay, that's compound interest. That's an increasing value because it's to the NT power. So you've got an increasing value, which looks like that. A is equal to PERT. Same thing. This looks very similar to what? To what I just showed you. See there? PE to the RT. You see that? Only this one's negative. 2.5 is going to talk about two things. 2.5 is going to talk about increasing values, which are these, and decreasing values, which is like A is equal to PE to the negative RT, which means that it's going to be going down. All right, so 2.5 is going to be talking about increasing and decreasing values. Now, why do we need to worry about this? Well, we only need to worry about it because there's certain applications of interest in business and cost. You always want your cost to be down. So you always have a relationship between the two, which is, you know, kind of opposite of each other. The old saying is, in order to make money, you got to what?
Spend money.
Thank you. Your parents did good. In order to make money, you got to spend money. And they're kind of opposite of each other. So that's what they're trying to get you to learn in this section of 2.5. Most of this can be done with your calculator when you're graphing. But as far as the derivatives, they want you to take the derivative. Then we're going to take the derivative of e to the kt, which is going to be P sub O, and take the derivative would be negative k e to the negative kt. So we're going to get into that. Oh, here we go. There we go, right there. There's your growth function. What? Thank you. There's your growth function, PERT, PE to the RT, and there is your decay. Now I'm going to put those on the, I want y'all to actually draw this in your notebook because it's very important that you understand that this whole section is focusing on these two graphs. That's what I was showing you a while ago. I didn't know they had a slide that actually did it better than mine. PERT, PERT, is right here. And PE to the negative RT is right here. Now, I'm associating everything with the compound interest / continuous interest, but it's the same concept. Growth, decay. Half-life is decay. Do y'all remember in biology talking about half-life and carbon dating? Okay, that's where the decay comes. There it is right there. And in accounting or business, you're going to be talking about growth talking about interest. I'm just trying to give you the applications that you're going to see with growth and decay. There you go. See, there's your half-life right there. I don't know why my computer is acting funny. Okay? You don't have to write that down. That's just showing you that, the natural log is also in with the KT and the K and the T. I'm not going to go into that too much. Okay, write this one down. Plutonium, a common product of functioning nuclear reactor, can be deadly to people exposed to it. Its decay rate is about 28/10,000%. What is its half-life? So write that question down, because you might see a half-life question like this you won't see it probably on my test, but you might see it on a standardized test. And when you do that, you're going to be using PERT with a negative exponent. Just a different rendition of PERT with a negative exponent. So finish writing that down. The reason I was late today is, for some reason, I was sitting, getting ready for class, and I got Dogecoin is up to 8 cents. Let's go, Dogecoin. I got a message on Teams that said you have been added to a team. And I was like, wow, me being added. What is it? Hold on a second. Sorry about that. But anyway, me being added to a team at Tri-County Tech, does anybody have a word for that? Unusual. It's usually me doing the adding. So I'm like, what have I been added to? And it says IT committee. And I'm like, usually you get asked before you get on a committee, don't you?
Not you, Hoover.
I don't understand. Okay, I'm getting some emails. Okay. I think I'm being put on a committee, but nobody has asked me. That's not the way to do things. Do you know what that involves? Come on, say it. You're getting an example right here, real world. What does that involve?
Communication?
Communication. This person did not communicate with me, and now I have sent emails, and 2 other people have replied saying WTF, basically. Because they have been, I've got 2 other emails that said they have been asked. I mean, they have gotten similar emails, but they have not been asked. This is an example of what communication, how important it is. I should have got an email asking me to be on a committee. Then I should have been added to a team. I'm giving y'all this example because y'all think this communication thing is bullcrap. It's not. In real life, it can cause major problems if you don't communicate.
Hubert, they can't just do you like that. They can't just do you like that.
I know. Here is one email. Listen, I just received these 2 emails. This is from the dean of Arts and Sciences. Good question, because I have received the same email and the site is empty. I do not understand. That's the Dean of Arts and Sciences. The other one that I just got says, I asked if I was being abducted. I was trying to be funny. And it says, you probably are being abducted by a rare species. Take lots of selfies and make sure you wear your seatbelt and sunscreen. I am including Jason on this to find out what is going on. So there is 2 emails. One is from a dean and one is from the CIO, which is the chief person. He's over IT. And both of them are saying, what the hell? Somebody's not communicating. You can't do that, people. Even in class, y'all can't do that, but y'all do it. But except for about 4 or 5 people in here, the rest of y'all suck. All right, so here's what we're going to do. T is equal to natural log. This is to find T. So T is equal to the natural log of 2 over K. And there you go. Now you remember you got to move your decimal 2 more places to the left. This will pan out in just a minute. Okay, natural log of 2 over 0.000028. And that is 25,000 years. So it will take its decay rate. What is its half-life? So 25,000 years is its half-life. So write that down so you'll have it. I'm not going to test you on this, but you might see a homework question with it and a standardized test question. Question, right, complaint. Not a big deal. The decay rate of cesium-137 is 2.3%, so move that. Dadgummit, what is up with this computer? There. Same thing. And down here, there's 3 good examples. Again, I'm not going to test you on these, but I do want to cover the decay and the growth problems. We hadn't got to them yet. Write those down, please. Yes, I think y'all have seen what one of y'all's people, meaning people in here that don't communicate, this is exactly what will happen to y'all that don't communicate in here. That's what's going to happen. You're going to add somebody to a team, and they're going to go, what the hell? And they're going to write an email, and it's going to cause a big problem, all because you didn't talk to the person before you sent them the email. Big no-no. Maybe this person's going to start a revolution.
Bad humor.
Everybody got it? Maybe I might put a couple of these questions on the test just to see if people listen. All right, we're going to move on. And I hope this is where we're talking about. Yes, this is it. The radioactive element, carbon-14, carbon dating, has a half-life of 5730, 5,730 years. The percentage of carbon presented in the remains of a plant and animal can be used to determine age. Archaeologists found that the linen wrapping from one of the Dead Sea Scrolls had lost 22.3%, that'd be 0.223, of its carbon-14. How old was the linen wrapping? So write that question down. Now this is a test question, and it's also a standardized test question, even though most people don't do it because they can't remember. But usually they give you a multiple choice with the formula, so you can try to at least plug and chug into the formula and try to get an answer. Okay? So you're going to use the decay function here because of half-life, and decay is, you know, same thing. So write it down. I'm going to write some of this information down. Half-life is 5730. And Dead Sea Scrolls equals 0.223 of carbon. How old was the linen wrapping? And of course, we got our decay formula. And find the decay rate for K. So K is going to be equal to the natural log of 2 over 5730. So let's take our handy dandy calculator. And that's going to be the natural log of 2 divided by, parentheses, divided by 5730. And that's 0.30. So that's going to be 0.000120996 12096.80943. Now, here comes the question, should I carry all that out? I would, because you always want the most, when you're plugging and chugging into a scientific formula, you want it to be carried out to the furthest digit, okay? And that there is the decay formula. So N is equal to the initial N, E to the negative 0.00012096800943 T. And basically, you're going to solve for T.
Which one is the decay formula, Hubert?
I'm sorry, what?
Which one did you say is the decay formula? Decay equals...
Right there. Right here.
Okay.
I'm showing you right here, but I can't go between right here. So here is your decay formula. And you're basically going to be taking the natural log of both sides because you're going to be solving for that T eventually. Okay, why is that taking me? Hold on a second. I don't know why this is showing up. Logged onto this morning at 8 o'clock. Sorry about that. And they're going to plug in that 0.00. Well, they're plugging it in, so 0.0777 is equal to N sub O, E to the point, and there's you plug it in. And the 0.777 trying to find where they got the 0.777. Hold on a second. Okay, well, they've lost me here. I don't understand where they got the 0.777. N sub O e to the negative 0.000t. Where did they get the 0.777? Am I missing something? Okay, 0.777 just came from absolutely nowhere. I understand plugging in that. I understand taking the natural log of both sides, getting t by itself. That's what we're supposed to do. But where I am totally, okay, am I missing something here? I love how they just stick a number in the formula and don't tell you where it comes from. Is anybody with me on that, or?
Yeah, I hate it.
I don't understand where they got the 0.777. I understand everything else. And they don't give you no explanation at all. And wait a minute. They've got N sub O.
Wait, is
on both
e to the
sides.
negative of what number that is equal to 0.777?
I'm sorry, I didn't hear you. Broke up. What'd you say?
Is e to the negative whatever that number is? I'm not about to say it. Equal to 0.77 because they have n to the 0 on both sides. Then e to, I guess, negative
I don't think
0.0001.
that would be it because it's not supposed to be on this side. And you can't, I see what you're saying. Well, I don't know. Let's see what it is, because they're skipping several steps. So that would be second E to the second answer. No, that's 1.0. That's not it. I have no idea where they're getting that number from. They're skipping a couple of steps, and I'm trying to see what they're doing. The N sub O and the N, they have, I don't understand why they've got N sub O on the left-hand side. Okay, they're doing something. They're doing a couple of steps, and they're not including it. Oh, why do they do this? I'm sorry. I didn't. Okay, I'm going to move on. We're going to come back to this. I'm going to come back to this because they are not explaining. I understand everything below that. I understand taking the natural log of both sides, getting t by itself. That's not a problem. From here down, I'm okay with. I don't understand where they're getting the 0.777. And they're leaving that out. It should be right above it. So I'll take suggestions if everybody's got it. Anybody got it? Anybody got a suggestion? I appreciate you trying to get that in there, but that e to the whatever came out to be 1. I'm looking anywhere. The half-life is not it. Wait a minute. We just Wait a minute. .223. They're using the complement. 0.223. 1 minus 0.223. Bet you $1 that's where it's coming from. 1 minus 0.223. Bingo. That they're using a complement. In other words, I didn't even catch that, so I read the question again. All right, my bad. I didn't read the question. When you go back to the question, when I can get to it, they found that the linen from the Dead Sea Scrolls had lost 22.3, which is 0.223, and the complement, I wasn't even thinking about that. The complement of 0.223 is 0.777. So go ahead and put that up here in red. Complement of 0.223 is equal to 0.777. In other words, if this is decayed, then this is what's what? If this has decayed, what is this? This is what is what? What's
That is
left?
how much is left of it.
There you go. So that's where the 0.777 is coming from. I'm sorry. I apologize. They could have put a little note in there to remind everybody to do the complement. Complement's way back in Math 120, which is probability and statistics. But it would have been nice if they had, put a little note in there. Then that would, help out tremendously. They suck. All right, so now I've figured that out. That's where it's coming from. So 0.777 times n sub O is equal to n sub O e to the blah, blah, blah. And then divide by the n sub O's cancel, because n is equal to what's left over times n sub O. Okay, so basically you're going to get 0.777 on this side is equal to, and they got it, e to the negative 0.00012 blah, blah, blah. And now to take the natural log of both sides, this is what I want to, from this right here is what I want to show you. All right, take the natural log of both sides. So the natural log of 0.777 is equal to the natural log of e to the negative 0.00012 dot, dot, dot. And what happens to the natural log of e? Goes out, Hubert. That's right, class. So the natural log of 0.777 is equal to 0.00012 dot, dot, dot times t, and I'm going to divide the natural log of 0.777. I'm going to divide it by 0.00012 dot, 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 0.00012 dot, 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 and t is equal to the natural log of 0.777 over 0.00012 dot, dot, dot. I'm going to do that in a calculator. Now this, from here down, that's what I want you to be able to do. Now I'm going to have to go back and I'm going to fill in the gaps back between here and here for you because they suck at it. And I'm going to fix that and do that for you. But I'm not going to do it today because we need to move on. All right. So I need to get to the derivatives of the exponents. All right. So take your calculator And we've already got say natural log of 2. Let me redo that for you. The natural log of 2. Well, sorry. Natural log of 2 divided by 5730. And that's not it. Natural log of 2 parentheses divided by 5730. And there's your scientific notation. Now I'm going to take the natural log of 0.777 and I'm going to divide it by the second answer. And that is 2085.79. Negative 2085.797. 2100 years. And that should be what they got. Okay, 2086. And the negative tells you that it's, way back. All right, now I want to get to the derivative. Okay, now interest rate, that's not a bad one to do. Let's write that one down. And this one's a whole lot more practical. Following the birth of their granddaughter, 2 grandparents want to make an initial investment of P sub O. They want to put in some money that will grow to $10,000 by the child's 20th birthday. So T is equal to 20. Interest is compounded continuously per PERT at 4%. What should the initial investment be, which is P sub O? Okay, so we're going to put 10,000 right there. Now this is more of a test question I would ask because it is a whole lot more applicable to real life. So P is equal to PERT, P-E to the RT. Okay, and I'm showing you, let's see, it says they want it to grow to $10,000 and the R is 0.04 and T is equal to 20. So plug and chug. So that's going to be 10,000 is equal to P sub O, E to the 0.04 times what? 20. Now, of course, first thing you're going to do, you want to get P by itself. So let's go ahead and condense this. 20 times 4 cent is what? Dang old 80 cent, or let's see, 20 times would be 80 cent, wouldn't it? So 10,000 is equal to P, E, let's check that because my decimals are terrible. Let's see, 0.08, 0.04, 2 times, I believe it would be 80 cent, times 20, or $8, 80 cent, 0.8, divide by what? E to the 0.8, divide by E to the 0.8, and 10,000 divided by parentheses E, I'm going to do parentheses, second E to the second answer. So they need to put in $4,500. So P sub O is equal to 4493.29, 4493.29. And of course, you always want to overestimate with money and with steel beams if you're doing a bridge or a apartment complex. You always want to overestimate. So P sub O, I would say 4,500 or 5,000. 4,500 bucks or 5,000. So if you have grandkids one day and you want to start a savings account for them, you need to put $5,000 in the bank for 20 years, and you're going to get a good payment out of it, unless the bank is stealing your money. Right now, is 4% feasible as a savings account? Yes or no? Does anybody know? How about our accounting students out there? Is 4% realistic right now?
Not at all.
That would be a hell to the no. Right now, you might be lucky to get 1.5% or 2% right now, because of 2000 to 2000, let's say 2008 to 2012ish, right in there, that recession we had. The banks, the interest rates on savings accounts, they've never recovered. So when you go into a bank and you say you want to put money in a savings account, they'll say, yes, we'll help you out, but they're thinking this person would be better investing in underwater basket weaving or something, because it's only like 1.5 to 2%. But they don't want you to know that kind of stuff when you graduate high school. Let's see what they got. Well, if I can find which one I'm on. Okay, now see, in the last problem, they overestimated. And in this problem, they leave it exactly the same. So did we get 4493? I think we did. Now that
yeah, we did. Yeah, we did.
That is a test question. That's the kind of question I would ask you on a test. Now, I don't think they're ever going to get to the freaking there. Finally. All right. Of course, here is the present value. This is PE to the negative RT. This is, and as I showed you before, and I'm going to show you again, it's very important. P is equal to PERT. A is equal to PERT. I can't write. A is equal to PE to the RT, and A is equal to PE to the negative RT. This is growth, and this is decay. Okay? If you took the derivative of this, it would be PE to the RT times the derivative of RT. And of course, that's probably going to be a number. If this was 4T, then this would be 4. And then you would multiply RT prime times PE to the RT. Now, if you did the derivative of the negative, it would just be a negative. All right, so, and let's put this, I want to highlight this yellow, meaning that you're going to take the derivative of that, what's inside, and multiply it by this number. Okay, same thing over here. I'm going to take the derivative of PE to the RT. So that's going to be negative RT prime times PE to the negative RT. And again, that negative RT If that R was a number, it would be like if this was negative 4t, it would be negative 4 times that. So that's where we're going with this. This is the questions I'm going to ask you on the test. So let's go ahead and see what they're getting ready to show you. And okay, Newton's law of cooling, they're going to tell you to take the first derivative of it. That's what they're going to tell you to do. Or they should. Okay, here is the exact, okay, this is where you get into your dang old CSI. A body is found slumped over a desk, dang old Law and Order. Dum dum. A body is found slumped over a desk in a study. A coroner arrives at noon, immediately takes the temperature of the body and finds it to be 94.6. She waits 1 hour, takes the temperature again, and finds that is 93.4. She also notes that the temperature of the room is 70 degrees. Does anybody know what 70 degrees is also called?
Room
Blank
temperature.
What?
Room temperature.
Yeah, but there's a sophisticated word. That's the redneck word. Anybody? It starts with an A. Ambient. Anybody ever heard that before?
Yeah, I
live in
think
the
I
South,
have on a
so
movie.
I don't think I've ever heard ambient temperature.
I'm sorry. I heard two people. Barry said he didn't think it's what?
I've never heard the word ambient temperature.
Okay. What'd you say, Miss Hollister?
I said I've heard the word ambient before, but never with
Let's see
temperature.
what it means. Ambient temperature. Ambient, I don't even know how to spell it. Ambient temperature. Is the temperature of the air surrounding a component, which is a 25-cent word for what?
Room temperature.
Mr. Barry, you were correct. I wanted to expand your horizons, Mr. Barry. And now you can use that whenever you're talking to your friends at the bar. You can use the word ambient temperature and you can sound sophisticated. You're welcome.
Hubert, I'm a dual enrollment student. I don't think I'll be going to any bars anytime soon.
You've been watching Bar Rescue? You need to watch it. All right.
Yeah.
I tell you what, there was a guy on there. He's $500,000 in the hole. And he told that guy, he said, I know more about bars than you do. And you're $500,000 in the hole. How arrogant can people be? How arrogant. All right. So here we go. The ambient temperature. So I'm going to write all this stuff down. First of all, the temperature of the initial temperature, and I'm writing this down. I'm showing you what I do here when I start a problem like this. Okay, the initial temperature is equal to 94.6. The second temperature, which is usually called T of I, is equal to 93.4. And the ambient temperature is equal to 70. And I'm looking to see if there's anything else. A body is slumped over a desk in a study. A coroner arrives at noon. Coroner arrives at noon. Now, why am I being very, why am I spending a lot of time on this problem? Because this is an actual decay problem that you might see in real life. Not that you would ever come up on a body and take the temperature. No, that's not what I'm talking about. There are a lot of people that go into forensics. A lot of people, okay? And that's where you would see this. Not a lot of people go into anthropology and what's the other one called? Anthropology and the other one. One studies cultures, the other studies artifacts. Anthropology and the other one. Oh, well, I can't remember. But do a lot of people graduate high school and college and go into forensics? Yes. Does it pay good money? Yes. Do you have to deal with a lot of crap? Yes. The more stress, the more money. All right, so the coroner arrives at noon. So whatever you're going to do, you're going to probably deduct it from noon because to find out when the person died. Okay, so we got all our information, and we're going to use our decay formula. Okay. Now, 94.6, that's our initial temperature, is equal to A to the E. This is PERT. Plus 70 because that's the ambient temperature. All right, so let's set this up, and we're going to use, let's see, we got negative, right? Yeah. We're using, hold on, that right there, you could, right here, you could use that. There you go. Okay, you could use that, the present value. So P of O, which is your initial, P of O is equal to P E to the negative K T, and that's where we're going with this. So 93.4, that's going to go right here. 93.4, I'm sorry, 94.6, sorry. Or is it the 93 point? Yeah, 93.4. Sorry. 93.4 is equal to, and that 24.6. Well, where did that come from? Where did the 24.6 come from? Equals 24.6 E to the K times 1 plus 70. That's where the 70, I mean, I've already skipped a step. I'm sorry. It is 94.6. I thought it was 94.6. I went to the wrong. 94.6 is equal to A to the E negative K times 0 plus 70. And now you subtract the 70, and that's going to give you negative 70, negative 70. 24.6 is equal A to the E to the 0. And what's A, E to the 0? What's E to the 0? A. So I've got T of T is equal to 24.6 E to the KT plus 70. That's our actual formula. Okay, that's our formula that we're going to plug into. So T of T is equal to 24.6 E to the negative KT plus 70. That is our actual formula. We're probably going to take the derivative of that because we're finding the cooling. And you take the derivative back here. If I want to find the cooling, I take the derivative. That's probably where we're heading with this. If I could find, there we go. So that formula, we got the formula from here to here, plugged and chugged. And now we're right here. Now, the initial, not the initial, but the second reading of the body is right here, 93.4. And we're going to plug that in And that's 1 hour after, she took the 1 hour after the initial temperature. So that's going to be 93.4. 93.4 is equal to 24.6 e to the negative k 1 hour plus 70. Minus 70. Minus 70. 23.4 is equal to 24.6 e to the negative k. Divide by 24.6. Divide by 24.6. I have no idea. So 23.4. 23.4 divided by 24.6. I got 0.9512. 0.9512 is equal e to the negative k. And at that point, let's see if we got 0.9. Let's see if we rounded 0.9512. Well, they're going on. We're right here. There we are. Take the natural log of both sides. I'm going to go to the next page. So 0.9512 is equal e to the negative k. And then take the natural log of 0.9512. Natural log of e to the negative k. And natural log of e goes out. And that's going to leave you with negative k is equal to the natural log of 0.9512 divided by -1. And k is equal to the natural log. I'm going to just take the natural log of that answer. So the second natural log, oh shoot, sorry. Natural log, second answer, close parentheses, enter, divided by -1. And that's going to give me the k value, which I got to plug back into 0.05001 ... And you're going to plug that back into the original formula. And there it is, 0.05. So now, and this is where you got to plug. So that's going to give you T of T is equal to 24.6 e to the negative 0.05 t plus 70. And that's where I am right there. They're going to ask us to take the derivative eventually. Let's see if they do it here. Okay, here, the regular temperature, we got to plug that in. So 98.6, to determine the time of death, you got to subtract it from this. So 98.6 and solve. So 98.6. 98.6 is equal to 24.6 e to the negative 0.05 t plus 70. All right, I want you to take a second or two and finish that out. Subtract 70, divide, take the natural log. make sure you can do one of these on the test, because I do want you to be able to find the time of death. And you'll see a homework question like this one. I would suggest you doing it several times, and we're probably going to do it several times Thursday, because you're going to send it to me if you haven't already sent it to me. And you see there is several parts, kind of like finding the equation of a line. There's several parts. So minus 70, and that's going to be 28.6 is equal to 24.6 e to the negative 0.05t. Divide by 24.6, divide by 24.6. And I have no idea, so I'm going to go and plug that in. So 24.6, let me clear everything, please. 28.6. 28.6 divided by 24.6. 1.1626 ... is equal to e to the negative 0.05t. And I'm going to go ahead and take the natural log of both sides. And that's going to be negative 0.05t. Divide by 0.05. Divide this by negative 0.05. So I'm going to take 1.16. I'm going to take the natural log of that. Second answer equals, and I'm going to divide by negative 0.05. 3 hours equals 3.01 hours. So that body's been dead for 3 hours. So the time of death would be around 9 a.m.
Hubert, that problem is a lot.
I know. I want you to be able to do it for a homework problem. The test problem will be a little bit easier to do because they'll shorten it a little bit. Let's see what they got. 3 hours, about 9 a.m. And I'm looking, okay. And that's pretty much it. That's all I want to do as far as 2.5. Now 2.6, let me go to 2.6 right quick. Now, are we talking a lot of questions on the test here? No. Okay. We're talking maybe 1 or 2 questions. So I don't want y'all to spaz out because we're not talking a lot of questions on the test. The majority of this test will be questions about derivatives of logs, derivatives of exponents. And if I could get to the, there we go. Let's see, that was 2, this is 2.6 right here. And we spent a lot of time on logs. Okay, we spent a lot of time on that. So, and this is the derivative of a to the x. And I want you to write that down right there. The derivative of a function or a number raised to the x power. If f of x is equal a to the x power, then f prime of x is equal to a to the x times the natural log of a. Now that's the way I write it. That's the way I write it. Now this is a test question. So make sure when you're getting ready for this test, make sure you can take the derivatives of logarithms, natural logarithms, and a to the x. Because that's going to make up 80% of your test. The review and 2.5 probably 10, 20%. So you're probably talking about 2 or 3 questions. So write that down and let's do some examples. I don't like to put the natural log first because that makes you think, well, where did the natural log come from? Well, basically, a to the x, and I'll basically, y is equal a to the x, okay, is equal to log base a is equal of x is equal to y. Okay, that's where that comes in. And you change that to natural log, which is log base e. Log base e is equal to natural log of x is equal to y. So that's where that right here as the derivative. So if I have f of x is equal 2 to the x power, then f prime of x would equal 2 to the x times the natural log of 2. So there's an example right there. Remember, I don't try to trick you. Now, I do try to challenge you. I do try to put problems on there that will make you think, like a negative or 1/2, but I'm not going to give you a crazy problem about carbon dating if the problem is yucky to begin with. I'm not going to do that. Why? Because when you get to the biology courses and the science courses that you need, most of y'all are in business and marketing, so you only need like 1 science course. You're never going to be taking, you're going to be taking the derivatives and the antiderivatives of cost and revenue in order to get what you need. So I'm sticking to the derivatives and the antiderivatives as far as now, if you were in engineering and this was engineering calculus, I'd be going the other way around and harping the science applications to you. Okay. Let's see what examples they give us. Okay, let's do these. Let's see. Slideshow. Oh, we just did that. Wow. I didn't know that was on there. All right, so let's do the second one. All right, 1/4 to the x power, 1.4 to the x power. Well, that's not much different from 2. So f of x is equal to 1.4 to the x power. So f prime of x would equal 1.4 to the x power brackets natural log of x. Now I put brackets in because I want people to understand that you write down what's there, and then you take the natural log of whatever's there. I'm sorry, 1.4. Okay, so 1.4 to the x, you rewrite that, and then you take the derivative of, the natural log of 1.4. Let me rewrite that. F prime of x is equal to 1.4 to the x power times the natural log of 1.4. Now, you could take that, put that in a calculator, multiply it by that, and get some weird number. That would be fine, but they just want it probably like that. There you go. All right, 3 to the 2x plus 1. Here you go. Now you're starting to get into some problems that are going to be nested, maybe nested. So f of x is equal to 3 to the 2 plus 2x plus 1, sorry. So that's going to be f prime of x is equal to 3 to the 2x plus 1. You're going to rewrite that. Then you're going to put in brackets natural log of 3. Not a nested. I thought it would be a nested. It is. I thought it was. And what's the derivative of 2x plus 1? Because this is in parentheses. I forgot to add the parentheses. If you add the parentheses, you don't forget. That's why I add them. And what's the derivative of what's inside? I'm going to show it to you in just a minute. The derivative of what's inside is 2. I thought that was nested when I saw it. So your final answer is 2 times the natural log of 3 times, I'm going to put it in brackets, 3 to the 2x plus 1. That should be your answer. When I started the problem, I said it was nested, but I forgot to put the parentheses around the 2x plus 1. Whenever you have a variable in parentheses, you've got to use the chain rule. And because I didn't put parentheses around that 2x plus 1, like I told you to do, I forgot to multiply by the 2. So there it is. There's the 2 right there. Let's see if they got another one.
Hubert, I got a question.
That's it on that one.
Hubert, I got a question.
Yeah.
Why is it natural log?
Go ahead.
But it's written like log natural.
What do you mean?
It's written like ln.
Natural log is ln. Ln is natural log. Is that what you're asking?
Yeah, I just think it should
LOG, there's 2 buttons. There's LOG and LOG base. There's LOG and LOG. LOG base 10 is LOG. LOG base C is natural log. Now, what's your question?
Oh, I was just saying that the natural log should be written backwards, like NL.
I never thought about that. That maybe you need to write the mathematics board and get that done, because that I don't know. I never thought about that. That's interesting. Natural log, yeah, but that's the way it's been written for umpteen years. So I guess they're gonna stick with it, Mr. Palmer. But that's the interesting natural log. I never noticed that. All right, let's go to the next slide, because these are important slides, because these are actual test questions. All right, let's try this one. Yes, 3 good test questions, and here's 3 more good test questions. Although these are pretty simple, that last one may be a chain rule. So y is equal to 5 to the x. F of x is equal 4 to the x. And y is equal to 7. And I'm going to put x squared in parentheses just as a precaution. And that should be 5 to the x times the natural log of 5. And that should be, and I'm just doing it here. This is going to be 4x natural log of 4. And this is going to be 7x to the second times natural log of 7. And then the derivative, those orange, what's the derivative of x squared, someone?
Two.
2 what?
2x.
2x. So this is equal to 7 to the x squared, 2x natural log of 7. And those should be your answers. Let's check them and see. Natural log of 5 times 5 to the x. That is correct. Natural log of 4 times 4 to the x. That is correct. And this one down here is 2x natural log of 7 times 7x to the 7. Now you could change this to 7 times 7. You could do that, but I'm not worried about that. They're using I'll show you what they're doing here. Just in case you don't know what they're doing. They're using the power rule. So I'm going to show you what they're doing there. If I could get the paper to work. We got this answer for the last problem. 7x to the second power times 2x natural log of 7. And they're bringing that 2 up to the, right there, power rule. And that'll give us 7x to the second times x natural log of 7 squared. And that's equal to 7x natural log of 49. So they're using the power rule. Technically, you could bring that 2x up here, but that would annihilate the 49. So they're leaving the x out front. Those are 6 good test questions that I would give you on a test. Let's see what else they got. I was hoping they'd do some more chain rules. Okay, go ahead and write this one down, which you should already know, but the derivative, if f of x is equal to log base a of x, f of x is equal to log base a of x. Then I can rewrite that, the derivative f prime of x is equal to 1 over the natural log of a times 1 over x, which is equal to 1 over x natural log of a. Now, where does this come from? Can anybody see where this comes from? From your, and you could rewrite this log base e of a, log base and 1 over x. You could change that to log base e. I don't care. But where does this come from? Does anybody want to take a stab at it? No calculus, all algebra. Where does this come from algebraically? I don't know if that's spelled right or not. All right, where does it come from? Where am I getting this from here? There's something that I'm using algebraically to get to here. What is it? Anybody know? the change, what?
Oh, change-based formula.
Yep. The change-based formula is where this is going from here to here. What is the change-based formula? The change-based formula, if I have the log of A to the x, then that's equal to log of x over the log of what? A. And they use this to get to this. Okay? I'm just telling you this. You don't have to know this. I'm just telling you that this is log of x over the log of a, which you could write natural log of x over the natural log of a, and that's where they're getting this. And if you wrote natural log of x over the natural log of a, then you could actually see where they're getting this right here. Because the natural log of x is 1 over x, derivative, and the natural log of a is 1 over the natural log of a, and that's where they're getting it. Okay, that's kind of, I'm going to put, yes.
Not to
Class
interrupt
over.
you, but I'm about to have to go to my other class.
I'm sorry, class is over. I'm sorry.
No, I'm just
You go
walking up the
ahead.
big hill.
Okay, who are you? Miss Ridings, you're here. Okay, we need to quit. Y'all need to go home. I got all into these natural logs, and I started
I gotta
rambling.
talk to you after
All right,
class.
Miss Ridings, let me check you off, and I'll shut off the recording, and
Hubert.
I will. Sorry about that. I'm so sorry.